So for the previous class, we have discussed a lot about our system. What is a system? What is a control system? And how to define the system and control system. Also, how to define our open loop control system. Up to this point, we have discussed. So we know familiar now the system, which is a number of components connected together to perform a specific task. Perform a specific task. So in the open loop control system, and also we will classify according to the control action, building upon the control action. We classify like this open loop control system and closed loop control system. Open loop and closed loop. We know generally that is open loop control system and what is closed loop control system and what are the some advantages and disadvantages. Now we need to move in depth with some proof. And we need automation nowadays. We need automation because our subject and control engineering and and automation. So that is why in our first unit we will discuss the fundamentals regarding the system and how to define the system. You can use the simple word independent of the output. A system in which the control action is totally independent of the output of the system is called the open loop system. We know a simple example we have studied already previous class. We are taking the electric ceiling fan as an example for our case to understand better, to understand easily. So in our electric fan, the switch is on, the fan is rotating. The fan is rotating. Without a regulator, we cannot adjust the speed. That's all. We cannot adjust the speed. So we are familiar about our control system. About our control system. Without a regulator, we cannot adjust the speed, but we can run the machine. We can run the machine. And the regulator is included. The system is called the control system. We can run the our load, our fan at different speed by adjusting the regulator, adjusting the input. That is a reference input is given, and the controller nowadays in our case regulator regulates the process. It is a process the machine is rotating, and the controlled output we can get the controlled output. So we can say simply definition. As per the definition, this is also the system in which the control action is totally independent of the output of the system. Okay, we can say we can consider number of example we know in our regular life. We are seeing electric hand dryer. Electric hand dryer. It's also one of the system. Number of components are connected to release the heat. To release the heat for to hand dryer. So the hot air is coming out. We can keep our hand just below and for drying. But the machine, the system is don't know how much your hand is dry. Once the switch is on or your hand is shown below, It releases some heat, releases hot air, but just don't know how much your hand is dried. So irrespective of our how much your hand is dried, it releases some amount of heat, hot air is coming out. So this kind of system is called open loop control. So we can say a number of examples. Automatic washing machine. Depend upon the preset time. Depend upon the preset time. Respective of washing is completed or not. Washing is completed or not. But if the setting preset time is running, if you set time is half an hour or 20 minutes, it runs like continuously 20 minutes. After the time reached, the machine will come to a stop. But no feedback. No feedback is missing. And like a bread toaster and automatic tea coffee vending machine. So depend upon the setting time, it's release the tea and coffee, tea and coffee, and also the light switch. Also the light switch. My dear cadets, any disturbance in the voice for surroundings? Only my voice is highlighted because somebody Uday Kumar, so for me, some network. Okay, 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 I understand. Balabharati, Gogulnath, Selva Pasam. How many of them joined now? How many of them joined? Nearly 14 students. Okay. What I'm asking, if any trouble in the voice surroundings because somebody taking the class near to me, but I am placing my mic near to my mouth. That is why I'm asking. And my voice is clear and no disturbance to hear my voice. Am I right? Balabharati, Gogulnath, Selva Pasam, Arnold. ஏதாவது டிஸ்டர்பன்ஸ் இருக்கா கவிபாலன் அரௌண்ட் மை somebody taken the class and I'm also shouting. That is why I'm asking. கவிபாலன்
சார்
வேற வேற வாய்ஸ் கேக்குதா?
நோ
என்னோட வாய்ஸ் மட்டும் கிளியரா கேக்குதா? ஏன்னா பக்கத்துல வேறவங்க கிளாஸ் எடுக்கிறாங்க, அதான் கேக்குறேன்.
இல்ல சார் நல்லா தான் சார் கேக்குது. கிளியரா இருக்கு சார்.
கிளியரா இருக்குல்ல? போதும். எனஃப்.
ஆ
ஓகே ஓகே ஓகே. தேங்க்யூ தேங்க்யூ கவிபாலன் விக்ரமன். தேங்க்யூ ஃபார் யுவர் குட் ரெஸ்பான்ஸ். Okay. So the lamps glow. We know if the switch is on, the lamp will glow. But the system don't know the light is required or not. If the switch is on, the lamp will on. That's all. But if the feedback is measured, how much illumination already available? Illumination depend upon the lighting is already there. If we measure the illumination, we can limit the input. Suppose so, it is possible. So for the open loop control system, we'll summarize some advantages. Very important question, and very much understanding is advantages. Very important. We know it's simple in construction. No need to measure the output. No need modifications in the controller action. No need to get the manipulated output. No need to change the process. Simple in construction and design, and also economical. Because once the output is need to measure, we need a sensor and we need to compare the input and the feedback, and we need some necessary action to be taken to meet the changes in the output. So these are the modification necessary. That is no need in our case. Advantages of open loop control system, and also easy to maintain. No need to watch the output. No need to watch the output, and which is generally stable. Generally stable. Input is on, output is close. Not a disturbance in between the input and output. It's convenient to use as output is difficult to measure. No need to measure. No need to measure. Depend upon the input, the output will close. No need to measure the output. That is why it is convenient to use. The output is difficult to measure. Okay, you should add some more points regarding the title, advantages of upper level control system, and also some disadvantages. We know it's inaccurate. We need to the run 1300 RPM, suppose for our machine, but we cannot get accurate. We don't know how much speed is running. Once supply is given, the machine is running. If we measure the output, then only we can adjust and we can get the accurate output. That is why it is not accurate. Also unreliable. So now also for the last point, without the feedback, we cannot correct the output automatically. So the any change in the output cannot be corrected automatically. Cannot be corrected automatically. Okay, these are some advantages, disadvantages. Now we are going to define the closed loop system. So for our closed loop system, you can see a number of examples. A system in which the control action is somehow dependent on the output. Dependent on the output. The control action is changes, which is by measuring the output. It's called a closed loop system. We can say a simple example, and with the help of the simple black diagram, we can understand the detail. We can understand in detail. We know we have a two path here. We have a two path, forward path and feedback path. This path is flowing in the forward direction. Only forward path is available for your open loop control system. For your open loop control system, only forward path is there. No feedback path. No feedback is taken for your open loop control system. Open loop control system. Okay, now taken we are consider simple example. One simple example. In the plant, what are the blocks are there? Reference input, transfer command input, and anyway, no need. The reference input is given in our comparator, and and also another one feedback signal. The transducer which can transfer the signal. That is why don't confuse the transducer. The feedback signal is taken. The feedback is converted in the form of acceptable form of the comparison. That is why we need transducer. We need transducer. Okay. To understand open loop, closed loop control system, and this is our controller. One more important block controller, which is also there in your open loop control system also, and our plant. Okay. Now consider in the plant or in our process, we need to run in the machine for to understand the closed loop control system. We consider one machine which is need to run 1200 RPM. Need to run 1200 RPM or 1000. Okay, 1200 RPM. We consider. Now our ultimate aim is to run this plant at 1200 RPM for some other purpose. Some other purpose. Now the reference input is, what is the reference input is needed? 1200, because our aim is to run this plant as 1200. 1200. 1200. Suppose if you measure the output already existing speed, that is 1000 RPM. That is 1000 RPM. If you measure the feedback with the help of the sensor, we need one sensor to measure the speed. To measure the speed. If you measure that is 1000 RPM and the feedback signal is generated and which is compared to the comparator, the input is 1200, input is 1200 and the feedback signal is 1000 RPM. Wait 1 minute. So here I can pick up any kind of GUI, graphical interface objects of this whole class. Gone directly into the command button, type this name, which carries this line command. So I can start drawing it in this drawing area. This is the drawing area where we need to draw this object. One more thing, we need to set the units, right? How to set this units? With this red color A, red A, then go to drawing utilities, then units. Gather this, specify units, length, height. Here it is. Okay, continue. By default, this values are given. Decimal, percent, 0 point dot dot. Okay, so our feedback is 1000 RPM. Now compare 1200 and 1000 RPM. The error signal is generated 200 RPM. So we need to increase the speed 200 RPM. Suppose if the machine is running at 1400 RPM, again we need to decrease the speed to 200 RPM to run 1200 RPM. That is our reference. That is our ultimate aim. So the controller generates the manipulated signal depend upon the error signal. Depend upon the error signal. This is implemented practically for all our closed loop systems. Different controllers and different plans and different feedback is taken from the output, depend upon the output, and the comparator will compare and generates the error signal. Generates the error signal. So the controller generates a manipulated signal. The manipulated signal which is given to the input to limit the speed as 1200 RPM. If it is runs at 1400, we need to decrease the speed. If it, if it is runs at 1000 RPM, we need to increase the speed to maintain. So the 200 error signal is generated. Depend upon the error signal, we need to manipulate the output. Manipulate the change the output. Change the output. Now the output is becomes 1200 RPM. So this is the complete block diagram for closed loop control system. Closed loop control system. And also from the fundamentals we know we should be able to know how to simplify the different blocks. I think just studied for your control system subject if studied control systems separately. But in our subject, parallelly, we need to understand the missing topics in our syllabus. Block diagram reduction, and during that study we were included some fundamentals in the control systems because the control system also very much important topic for your competitive exams, like our measurements, like our electrical machines, MET. So this is also we need to add more fundamentals regarding the control systems because each and every block to represent one important topic, how to take the feedback, how to give the reference, and how to simplify what are the modification is possible in our blocks. So we can understand with the help of the block diagram reduction also. And also we should understand what is the uh, transfer function representation. Then only we can analyze the system easily. Can analyze the system easily. Okay, so from this closed loop control system block diagram, what we are understanding from this topic, the output, the response is depend upon, is consider the previous output. the previous output. That is our definition says. That is our definition says. That is our definition. A system in which the control action is somehow dependent on the output. The system is dependent on the output because our system. This is our system, the plant and the controller. Like our fans, we are taking the fan speed. Suppose for example, if you measure the speed, 1,200 1,000 RPM is running, and if you compare and generate the error signal, if we need increase 200 RPM only, we adjust the mode. If you are having the input, if you are having the possibility to change the input, automatically we should move the controller to increase the speed to 200 RPM only. We can get accurate speed. Accurately, we can run our machine at 1,200 RPM. So in this way, we can get the accurate speed, and the system also reliable. We can easily change. If any modification in the output, automatically is adjusted themselves. If the feedback controller is available, so, summarize some advantages. Summarize some advantages. And also one example. We know some regularly we are understand if you use our iron box, each and every material, the clothes, we need different heat. If we fix one uh, necessary heat, automatically, if the heat reached, automatically the supply is switched off. The system is arranged like this. Close look, you measure the already existing heat. The heat is reduced and the switch is on, the supply is on, connected again, and to increase the speed for mentioned speed or depend upon our requirement, the heat is generated. Heat is generated. So the heating elements are controlled by the output temperature of the iron. And also, and some more example we can say in the stabilizer. We are using the stabilizer in our TV or fridges. If the voltage increases beyond a certain limit, suppose 220 voltage is the normal voltage level. So why we need stabilizer? Why we need stabilizer for our supply before the electronic components? If the voltage increases beyond such limit or decreases beyond below some limit, our electronic components are will get damaged. The property of electronic the component which is stable if the voltage is in between the mentioned level. So we need to maintain the voltage with the help of this stabilizer. If the voltage is increasing, we need to drop some voltage. If the voltage is decreasing, we need to increase some voltage. With the help of some electronic components are nowadays using xenodiode and series voltage regulator. With the help of the uh, transistors also is possible to design some more regulator. Okay. Here we should summarize the advantages. What are the advantages? The closed loop control systems are more accurate. Even in the presence of non-linearity, we will check, we will verify what is non-linear, what is linear in the next class. Highly accurate. As any error is arising is corrected due to the presence of feedback signal. We know if the error is possible, if any deviation in the output, if any deviation in the output, automatically it is adjusted with the help of feedback measurement of feedback. And we can adjust the bandwidth also, facilitates automation. Nowadays, automation main important discussion of our topic is to implement our subject, the automation. Now in the automation industry, automatically it is controlled by measuring the feedback. The sensitivity of the system may be made small to make system more stable. System is less affected by noise. So, and also some disadvantages. It is costlier. Why? We need to measure feedback signal. We need sensors, and we need to get the manipulated signal. We need different controllers, and we need we need to comparator. Some more components are added. They're complicated to design, require more maintenance. Feedback leads to oscillated response. We need to concentrate the oscillation, dampened oscillation, and overall gain is reduced due to the presence of feedback. Stability is the major problem. We should take care to get the feedback signal. So, there's some advantage and disadvantages, and very important discussion in our according to our syllabus. According to our syllabus, the very important topic also we need to add comparison. We need comparison. We can understand with the help of some uh, one important video to understand the basic up till now what we discussed in detail. Students can able just inform to update me able to share the voice also. Able to hear the voice, video voice. Anyone please respond? Can able to hear the video voice? Okay. So the important system for a closed loop control system, the vehicle speed, if you need the control, which is measured with the help of the speedometer, and eyes and brain is very acting now. The error is detected and generate the error signal. We can limit manually. Apply the controller helps of legs and hands, and you will move. And so depend upon if any obstacles we observe, professionally will drive our vehicle safely. The system is operated safely because of the closed loop system. The speed is controlled. Vimal Raj, anyone student kindly respond. Can you able to hear the video voice? Video voice கேக்குதுங்களா? Anyone student please?
கேக்குது சார்.
Here.
சார்
Okay, ma. Okay, ma. That is why. Without hearing the video voice, no need. Uh, so in this way, we will run some videos to understand our basics. I will repeat once again this video for better understanding. Whatever the concepts we discussed, displayed in the form of in this video also. Directly open loop control system. The lamp filament is controlled therefore direct switches. And also we have some advantage and disadvantages we have discussed previously. The closed loop control system also the best example in the car. And summarize the advantage and disadvantages of the system. Okay, we'll continue the same. I think I'll have some relevant videos in the next class. Once you verify the attendance, I will call everyone. Shouldn't be aware the time of taking classes. When call one student, you should respond, please. So note down the absent is Vignesh EAME 18119 and Aravindan EAME 18123. Bharadiraj AME 18126 and Amarnath AME 18165. 165, yes. 1, 2, 3. The 4 students are absent. 21 is present out of 25.
Sir, Vignesh network issue, sir.
Vignesh is available?
Network issue. Connect out.
Yes, yes, not able to understand. என்னப்பா
கனெக்ட் ஆகல சார் அவனுக்கு நெட்வொர்க் இஷ்யூனால.
அப்படியாமா சரி சரி. ஆஃப்டர் திஸ் கிளாஸ் ஜஸ்ட் இன்ஃபார்ம் டு ஹிம் டு மெசேஜ் மீ.
ஓகே சார்.
ஓகே. விக்ரம் நான் ஈவினிங் தான் சப்மிட் பண்ணுவேன். அதுக்கு முன்னாடி என்கிட்ட கான்டாக்ட் பண்ணணும். பாரதிராஜ், அரவிந்தன் and Amarnath. Just inform to them these are the absentees. Vignesh, I will consider if he responds proper. Okay, thank you all. I think this session is very useful to understand the basics, fundamentals of our concepts. In this way, we will continue our session with some relevant videos also. And this is also an important topic. The open loop and difference compared to the difference between open loop control system and closed loop control system also. Important question also. We should read it. Each and every line is very important. Now I will continue the line earlier. This is how to classify, how to understand the different classification and how to define. Similarly, we will proceed the basic servo systems and also the Laplace transformation is necessary to simplify for simplification. Move parallelly, but we will concentrate our topics. At the same time, we will consider our fundamentals regarding the control system to understand the basics. And this kind of questions only asking for your competitive exams, the fundamentals. This is not in depth, just basic. At the time of discussion, we can understand what is zero system, first order, second order. If the one system is given, identify the system is 0, 1 or 2, like that. So one practical example also given. We should write on transfer function, then we can understand the order of the system. Like that, the question we, we should be able to face the technical questions also. Okay, we'll continue in the next class. Thank you for your response. Thank you all.